Question 9 contains a pair of equations to solve. In the first one, part A, I would probably choose to solve this by using fraction busters. If I look at my two denominators, I have a 5 and a 10, and I know that if I multiply both sides of that by 10, it will eliminate the fractions entirely. So that's my plan. I'm going to multiply both the left-hand side and the right-hand side by 10. And in the case of the left-hand side, you can see when I divide a 10, oops, I want to grab my highlighter there. When I multiply this 10 and a denominator of 10, that creates a giant 1, right? 10 over 10 is 1. So this side just simply ends up becoming 15 plus 3x. On the other side, it's a little bit more complicated, but not much. You can see I have a factor of 10 and a factor of 5 in my denominator. 10 divided by 5 is 2. So what I need to do is distribute this factor of 2 to the 3x minus 3. So I'll write this. It's 2 times 3x minus 3. If I distribute that 2, it's a 6x minus 6, and that equals 15 plus 3x. We can subtract 3x from each side. If I do that, I get on this side a 3x minus 6. Again, I took away 3x from the left-hand side. And when I take away 3x from the right-hand side, I'm left with just 15. If we add 6 to each side, we have that 3x is 21. And again, the final property of equality, division property of equality, if I divide both sides by 3, I get that x is the number 7. And as convincing as that may or may not look, it's not until you plug in the value and check that it works that it actually works. So I suggest grabbing a calculator and just quickly evaluating the left-hand side and the right-hand side. And I believe that both sides end up being equal to 3.6 when you plug in 7. So for part A, x is 7 is our solution. For 10, I don't have the fractions to deal with. Part B, I don't have the fractions to deal with, so we're just going to go ahead and distribute the 3 on the left-hand side. So this becomes 12x plus the number 21. Over on the right-hand side, you can see I have 12x minus 15. Now, when you notice that you have exactly the same number of x variables on both the left and the right, you can see there's 12 of them here and 12 of them here. And I subtract that from both sides, right? I'm going to take away 12x from each side of the equation. Notice what this equation becomes. It ends up becoming negative 15 is the same thing as 21. That is clearly a contradiction, right? Negative 15 is not 21. So we know at this point that this is there's a contradiction here. There's no solution. So we would just write no solution.